Hey team, welcome to the numbers game. I'm Coach T, and in this tutorial, we're going to be using the epsilon minus delta definition to execute a limits proof. Now, before we get started, make sure to subscribe to the channel for notifications on more math tutorials. All right, now let's take a look at this example. Our example says use epsilon minus delta to prove that the limit as x approaches 3 of 2x squared minus 7x plus 3 over x minus 3 equals 5. And the first thing that we'll do is go over the epsilon minus delta definition. It says for all epsilon greater than 0, there exists a delta greater than 0 such that if the absolute value of x minus a is less than delta, then the absolute value of f of x minus f of a is less than epsilon. So for the example that we were given, we need to show that for all epsilon greater than 0, there exists a delta greater than 0 such that if the absolute value of x minus whatever x is approaching, which for us is 3, is less than delta, then the absolute value of f of x minus whatever the limit equals, which for us is 5, is less than epsilon. So before we start to execute our formal proof, we'll need to do a bit of scratch work or analysis first. We'll start off with the absolute value of f of x minus f of c. And our f of x is going to equal 2x squared minus 7x plus 3 over x minus 3. And then we've already identified f of c as 5. We can simplify this by factoring the numerator, so 2x squared minus 7x plus 3 factors to x minus 3 times 2x minus 1, and then we'll leave x minus 3 in the denominator, and this is still minus 5. At this point, we see that this x minus 3 and this x minus 3 cancel out, so that'll leave us with the absolute value of 2x minus 1 minus 5. And this, of course, leaves us with the absolute value of 2x minus 6. At this point, I'm going to factor out 2. So that's the absolute value of 2 times x minus 3. I'll move that 2 to the outside of the absolute value. So that's 2 times the absolute value of x minus 3. And that's enough simplification, so I can say this is less than epsilon. Now, if 2 times the absolute value of x minus 3 is less than epsilon, then that means that the absolute value of x minus 3 is less than epsilon over 2. And of course, I got this by dividing both sides by 2. And finally, I'll set epsilon over 2 as my delta. So now that we've identified delta, let's get into our formal proof. Of course, we'll start with setting all epsilon greater than 0. And then we'll let delta equal epsilon over 2. Then for the absolute value of x minus 3 less than delta, we have the absolute value of f of x minus 5. This equals the absolute value of 2x squared minus 7x plus 3 over x minus 3 minus 5. And we're basically just going to follow what we did in the analysis. So we'll factor the numerator. Simplify to the absolute value of 2x minus 1 minus 5, which equals the absolute value of 2x minus 6. Factor out 2 to the outside of the absolute value. And at this point, we can say that 2 times the absolute value of x minus 3 is less than delta because we've already identified delta as epsilon over 2. And epsilon over 2 is less than epsilon. Hence, we've proven that the limit as x approaches 3 of 2x squared minus 7x plus 3 over x minus 3 does indeed equal 5. And there you have it. Using the epsilon minus delta definition, we've proven that the limit of our function does in fact equal 5. If this video was helpful for you, give it a thumbs up, like the video, and also subscribe to the channel for more math tutorials. I'm Coach T, and thanks for watching the numbers game.